This video is going to cover our lecture for phase change and heat of fusion. We start off with asking ourselves what is a phase change and what energies are involved in phase changes. So we start off with imagining this experiment of solid ice melting into water, liquid, and that liquid is evaporating into a gas. So if you look here, I have the steps 1 through 8. We start off with ice at -20 degrees Celsius. So let's say this cube here is -20 degrees Celsius, right? At first, we don't see any changes when we apply heat, and that is because ice doesn't melt until 0 degrees Celsius. So we apply heat to get this -20 degrees Celsius to 0 degrees Celsius. When we're applying this heat, we don't see any physical changes. So the cube of ice still remains a cube of ice. So our next picture here, let's say, is around 0 degrees Celsius. So that's when we first initially see a little bit of liquid melting from the solid ice. We keep applying heat and keep applying heat, and the temperature of ice at 0 degrees Celsius doesn't get hotter until the entire ice is dissolved. So our next picture here is still at 0 degrees Celsius, even though we have more of the ice melted, but we still have some ice present there. So up until we get to the all liquid phase, where our 0 degrees Celsius can start increasing in temperature. So here, if you look at our liquid image, our ice is completely melted and the temperature of the water just starts to increase. So now let's say we go from 0 degrees Celsius to 100 degrees Celsius here. Once we hit the 100 degrees Celsius, our water starts boiling. So once the water starts boiling, we have steam coming through. So here, our next picture is at 100 degrees Celsius. Our water is boiling, we got some steam on top, and then we keep boiling, and we have a little bit of water left here, but we're still at 100 degrees Celsius, but we have more steam, right? Once all of our water is evaporated, so our last and final image here, we have no water left. So at this point, when there's no more water left, we can heat the steam to be above 100 degrees Celsius. So phase change is any change from one physical state to another. So we go from gas to liquid, liquid to solid, solid to liquid. Any phase change, any changes in physical state is called a phase change. Phase in particular is any part of the system that looks uniform or is homogeneous throughout. So going back to our image, a solid is a phase, a liquid is a phase, gas is a phase. Any mixtures of them two is not a phase. If you have ice and water, that is not considered a phase. Next, I'm going to go over specific heat. Specific heat is the amount of heat in calories necessary to raise the temperature of 1 gram of any substance by 18 degrees Celsius. This is by definition. Each substance has its own specific heat. You do not have to memorize this. For any questions, you will have the specific heat values provided to you. Here's a table of some common substances that we use specific heat for. Water specifically has a specific heat of 1 calories per gram Celsius. As you see, ice Ice is still H2O, but the specific heat changes because ice is a different phase. The specific heat for ice is 0.48, and same for steam, 0.48. So it is easy to make calculations involving specific heat. We calculate specific heat by an equation of the amount of heat is equal to the specific heat, which is found from the table, multiplied by the mass, multiplied by change in temperature. Change in temperature is calculated by temperature final minus temperature initial in degrees Celsius. Our next table here is energy required to heat 1 gram of solid water at negative 20 degrees Celsius to 120 degrees Celsius. So this is pretty much the picture I went over before. We start off with negative 20 degrees Celsius and we have to heat it up to 120 degrees Celsius. But remember, it's not just one phase that we're changing, there's multiple phases we go through. So let me go over an example for you to understand better. This is example here. Calculate the heat required to raise the temperature of 1 gram of ice at negative 20 degrees Celsius to water vapor at 120 degrees Celsius and compare the results with the data in the table above. So we begin with the ice, right? So specific heat of ice we got from the table is 0.48 calories per gram Celsius. The amount of heat required to raise 1 gram of ice from negative 20 degrees to 0 degrees is going to be calculated by the equation that I just went over, the amount of heat, which is the specific heat, times the mass, times delta T, which is the change in temperature. So our first step, we're going to go over, so we're going from negative 20 degrees Celsius to 0 degrees Celsius. So this is our step 1. The math is already done here. We end up with 9.6 calories for the amount of heat required to warm up our solid ice from negative 20 degrees to 0 degrees Celsius. So after the ice reaches the 0 degrees Celsius, additional heat causes the phase change. So now we go from our solid to liquid. The heat necessary to melt 1 gram of any solid is called heat of fusion. So our next value is going to be called the heat of fusion of ice. If we look on our table here, heat of fusion of ice right here is 80 calories per gram. So it will require 80 calories to melt 1 gram of ice. So we're still at the 0 degrees Celsius, right? Remember, at 0 degrees Celsius, we have our solid melting until it is completely liquid. Once it's completely melted, then our temperature can rise again. So now we go back to the specific heat of liquid water. So at this point, we have our liquid getting warmer, and the specific heat for that is 1 calories per gram Celsius. So it requires us to have 100 calories to raise the temperature of 1 gram of the liquid from 0 to 100 degrees Celsius. So now we're warming up our water from 0 degrees to 100 degrees Celsius. So our water is just getting hotter and hotter and hotter until it reaches the boiling point. So once our liquid reaches 100 degrees Celsius, we're at the boiling point of water. Now at this point, remember I went over, the boiling water stays at 100 degrees Celsius until all of the water that's boiling is evaporated. So the amount of heat necessary to vaporize this 1 gram of liquid at the boiling point is called heat of vaporization. And for water, that is 540 calories per gram. Once all the liquid water has vaporized completely, then we can increase the temperature of the vapor, the gas, and that is the specific heat of steam, which is 0.48 calories per gram. So now here, if you remember, our initial problem said that we have to go from negative 20 degrees Celsius to 120 degrees Celsius. So here's the steps. We go from negative 20 degrees Celsius to 0 degrees Celsius first. Then our second is 0 degrees Celsius to 100 degrees Celsius. And then we go 100 degrees Celsius to 120 degrees Celsius. So this is melting. This is the warming up. And then this is vapor. So where does 9.6 calories come from? Remember our equation? We had specific heat times mass times delta T. So our specific heat right here for steam is 0.48. Our mass was 1 gram, right? And then we have our delta T. So we have 120 minus 100. So when you do the math here, that's where you get the 9.6 from. So let's look at this data for heating the 1 grams of water from negative 20 degrees Celsius to 120 degrees Celsius. This graph is called the heating curve. It's a graphical representation of what I just went over. So we start off with negative 20 degrees Celsius, right? We're warming the ice up to 0 degrees Celsius. That requires us to have 9.6 calories of heat. Then we're staying at 0 degrees Celsius until our ice is completely melted, right? That's where we have this straight line coming. To melt our entire ice, we need 80 calories of heat. And then we start warming up our water. So that is our line here. We're warming it up, warming it up, warming it up until we go from 0 degrees Celsius to 100 degrees Celsius, right before the boiling point. And that requires 100 calories of work. And then at 100 degrees Celsius, we keep boiling it, but at this point, our boiling water is changing to steam. So it's changing to steam until all of the water is vaporized. That requires 540 calories. So once everything is steamed completely, then we can heat the steam to be a warmer temperature. So for our example, it asked us to go to 120, and that only requires 9.6 calories. So when we add all of that, the total energy required is 739.2 calories of heat to go from negative 20 degrees Celsius of ice to 120 degrees Celsius of steam. The last note here says, notice that the heat of vaporization is greater than the heat of fusion because all intermolecular forces must be overcome before the vaporization can occur. In particular, while many hydrogen bonds remain in the solid to liquid transition, Virtually all hydrogen bonds must be broken in the liquid to gas transition. Hence the difference between the heat of fusion, which is 80 calories per gram, and the heat of vaporization, which is much, much, much greater, 540 calories per gram. So that is the end of our heat of fusion and phase change. It is important for you to understand this. You will have a problem similar to this on your final exam, asking you to calculate. So for this example, it was going from -20 degrees Celsius to 120. If I were you, I would just write all this down, the example that I just went over, so you can see how the math processes, and when you have your final exam and it asks you to calculate something similar, you can refer back to your notes that you took. So that's it for today. We do not have Cengage homework assignments. We only have the 2 Beyond Labs packets to do. Other than that, if you have any questions, please email me and I will get back to you as soon as I can.